Hello and welcome to the chapter on Computer System Overview. This is the part 2 of this particular chapter and today we are going to deal about memory. So let's get started with what is a computer memory. See, we as human beings retain information in our memory. That's the human memory. Similarly, computer retains information in its memory known as computer memory. So what's the formal definition of computer memory? A computer memory is the storage space in the computer where data and instructions required for processing are stored. So in order to store the data and instructions in a computer, we require a storage space which is known as computer memory. The memory of a computer is divided into large number of small parts called cells. So as you can see here, this is a part of the computer memory. The computer memory is divided into large number of small parts. These are known as cells. Each of the cells is further broken down into small parts known as bits. As you can see, this is a complete cell and one cell is divided into certain smaller parts. These small parts are known as bits, B-I-T-S. What is the meaning of bit? A bit means a binary digit which is either 0 or 1. Each bit within a cell has a unique address which is in the range of 0 to memory size -1. Now each of these bits within a cell has an address. This address is known as the memory address. What is the range of this memory address? The range is from 0 to memory size -1. Now here, what is the size of the cell that you are seeing in your screen? The size is 8. Therefore, the memory address will be from 0 to memory size -1. That means it will be from 0 to 7. Because the size is 8, the memory address is from 0 to 7. I hope that this is clear. Let's go to the first type of memory known as primary memory. What is primary memory? The type of memory that holds only those data and instructions on which the computer is currently working is called primary memory. See, in a computer there are lots of data and information, but a computer will work only on a group of data and information, or only on, let's say, only on one software it will work at a time. So that type of memory which holds only those data and instructions on which the computer is currently working or presently working, it is known as primary memory. So the primary memory of a computer is divided into two types. It is RAM and ROM. Further, RAM is divided into two types known as SRAM, that is static RAM, and DRAM, that is dynamic RAM. Similarly, ROM is also divided into certain parts known as PROM, EEPROM, EEPROM, flash EEPROM, and mask ROM. We will discuss about all the different categories of RAM and different categories of ROM also in the upcoming slides. So let's begin our discussion with RAM. RAM stands for Random Access Memory. It is a type of memory in which the memory cells can be accessed for information transfer from any desired random location. Now, if we are accessing the memory cells from a random location rather than in a sequential manner, it is known as RAM. It is a volatile memory, hence it is temporary in nature. Volatile memory means, see, RAM is a type of memory in which the currently running programs are stored. Therefore, as we switch off the computer, the information from the RAM gets away. Therefore, it is said that it is a volatile memory and hence it is temporary in nature. What are the different types of RAM? RAM is divided into two types. First is dynamic RAM and second is static RAM. This is how a typical RAM looks like. Let's start with dynamic RAM, which is the shortened form of which is DRAM. Dynamic RAM, it is composed of capacitors. This is how a capacitor look like. If you open the motherboard of a computer, or if you just observe the motherboard of a computer, you will see these types of capacitors. Capacitor stores charge. It is typically used as main memory of a computer. Now, main memory of a computer is made up of DRAM. It is to be refreshed periodically to maintain the charge in the capacitors. As I have already mentioned that capacitors stores charges. Now, in order to retain or maintain the charge of the capacitors, these RAMs are to be refreshed periodically. Its access time is more, that is, it is slower. Now, what do we mean by access time? Access time means the time taken to retrieve data from storage is called access time. Now, as we request the data, you will not get it immediately, right? It will take some time. That time is known as the access time. It is the time taken to retrieve data or take out data from the storage. Here, in case of DRAM, the access time is more. That means it is a slower form of RAM. Next up is SRAM, that is static RAM. It is made up of flip-flops. What are flip-flops? Flip-flops are binary cells capable of storing 1 bit of information. Flip-flops, they store 1 bit of information. Flip-flop is a very detailed mechanism. You will get it in your higher classes. Now you just need to know that static RAM is made up of flip-flops and dynamic RAM, it is made up of capacitors. It is typically used as cache memory in a computer. Cache memory is a very high speed memory. We'll get cache memory in details after a few minutes. Now, in order to design the cache memory, static RAM is used. It does not require periodic refresh to maintain data. Since it is made up of flip-flops, therefore, no periodic refresh is required in case of SRAM. It has faster access time. Faster access time means it is a faster form of RAM. Let's go to ROM, which is known as read-only memory. It is a memory unit that performs the read operations only. Now, in ROM, the information is already stored. You just have to access the information. That means it performs the read operations only. This is how a typical ROM looks like. It is a non-volatile memory. That means information stored in ROM is permanent. The information stored in ROM is made permanent during the hardware production of the unit. When ROM is made by the hardware manufacturers, at that time only the information in the ROM is permanent. It stores instructions required for booting the computer. Now, what is the meaning of booting? When we press the power on key in the CPU, then it takes some time to start the computer. Now, for starting the computer, certain programs are required. Okay, and who helps in starting the computer? ROM helps in starting the computer. So, booting is the process of starting the computer. What are the different types of ROM available? They are PROM, EEPROM, EEPROM, Flash EEPROM, Mask ROM. Let's start our discussion with PROM. PROM stands for Programmable Read-Only Memory. This is how a PROM looks like. It is also known as OTP, that is one-time programmable. That means you can program a PROM only once, not more than once. Once the PROM is programmed, the information written is permanent and cannot be erased. Once you write information in the PROM, you cannot erase the information again. Therefore, while you are manufacturing PROM, if some mistake occurs, then that chip is discarded and the new PROM is to be created, which is a disadvantage of PROM. As you can see in the last point, if a PROM is programmed with an error or needs updation, the chip is discarded and a new PROM is created, replacing the old chip. Next, let's go to EEPROM, which stands for Erasable Programmable Read-Only Memory. EEPROM is a type of ROM that can be erased and reprogrammed if needed. Now, the distinguishing feature between PROM and EEPROM is that EEPROM can be erased after writing the information also. Now, how is reprogramming done in EEPROM? Reprogramming is done by exposing the chip to UV radiation. Now, the chip, that is EEPROM, is exposed to UV radiation, and in that manner reprogramming is done in case of EEPROM. An EEPROM chip is distinguishable by small quartz crystal circle window that exposes the chip so that it can be reprogrammed. Now, as we have already learned that reprogramming is done by exposing the chip to UV radiation, therefore this is how an EEPROM looks. In the middle, you will see that there is an exposed part. Why this exposed part is there in EEPROM? So that it can be reprogrammed by exposing it to UV radiation, which is not the case with PROM, where no exposed part is there, because it's not required, because it cannot be reprogrammed. PROM cannot be reprogrammed, but EEPROM can be reprogrammed using UV radiation. I hope it is clear. Let's go to the next type of ROM, which is EEPROM, which stands for electrically erasable programmable read-only memory. What is EEPROM? It is a PROM that can be erased and reprogrammed using an electrical charge. In case of EEPROM, we can erase and reprogram using UV radiation, but here in case of EEPROM, the reprogramming is done by using an electrical charge. This process of erasing electrically is faster as compared to EEPROM. Since we are using electrical charge here, the process of erasing is faster as compared to EEPROM. In this process, selective bytes can be erased, unlike UV EEPROM, which erases fully. In case of EEPROM, we have to erase the entire chip even if there is a small mistake. But in case of EEPROM, we can erase selective bytes also. Therefore, it is better as compared to EEPROM. This is how EEPROM looks like. Next, let's go to flash EEPROM. What is it? It is similar to EEPROM but faster. That means the mechanism of flash EEPROM and EEPROM is the same, but flash EEPROM is faster as compared to EEPROM. The eraser of the entire contents takes less than a second. In less than a second, you can erase the entire contents from flash EEPROM. The data from flash EEPROM is erased fully and not selectively. You will not erase the data from flash EEPROM selectively. You will erase it fully. This is how flash EEPROM looks like. Let's go to the last type of ROM, which is the mask ROM. What is it? It is a type of ROM in which the contents are programmed by the IC manufacturer. Now, whoever makes the ROM, they will program the contents of mask ROM. It is masked off during production. Masked off during production means how the programming is done, you cannot see it. This is done in order to protect the integrity and the privacy of the hardware manufacturer. Masking primarily serves as a sort of intellectual property protection so that other manufacturers cannot copy their code, reserving reproduction of the product to the IC manufacturer, so that it serves as an intellectual property protection. Therefore, ROM in case of mask ROM is masked off during production. This is how a mask ROM looks like. Now we are done with primary memory. Let's go to secondary memory. So what is a secondary memory? It is the type of storage devices that is used to store large amount of data permanently. See, in case of primary memory, you cannot store large amount of information. For example, when you buy a new computer, what is the typical size of RAM? The typical size of RAM is about like 4 GB or 8 GB. But what is the size of the hard disk or the solid state drive that you have? Its typical size is maybe 500 GB, maybe 1 TB, like that. So those are known as secondary memory. Secondary memory are storage devices used to store large amount of data permanently. For permanent storage, secondary memory is used. So secondary memory, let's see some categories of secondary memory. First is magnetic storage based secondary memory. The examples are hard disks and floppy disk. These have some mechanical moving components. These are example of magnetic storage based secondary memory. They store information permanently. Second category is flash memory. They do not have any moving components, therefore it is faster as compared to magnetic storage based. Examples are pen drive and solid state drive, but they are expensive as compared to magnetic storage based secondary memory. Next type of secondary memory is the optical media. They use some property of light. They are typically circular in shape, which consists of CD, DVD or Blu-ray disc also. Next, let us go to the cache memory. What is cache memory? It is a high-speed memory located inside the CPU in order to speed up access to data and instruction. Now, if you require data and instructions immediately, then cache memory is used. Typically, the recently used files are stored in cache memory so that CPU can access it immediately. Now, how does a cache memory work? Let us see in brief. It is a portion of memory made up of high-speed SRAM. Now, cache memory is made using high-speed SRAM, that is static RAM. Whenever some data is required, the CPU first looks at the cache. Now, instead of looking in the secondary memory or in the dynamic RAM, at first the CPU looks at the cache memory whenever some data is required. If the data is found in the cache, well and good, CPU does not access memory and hence the process becomes fast. So since it is why it is a high speed memory? Because it is located in the CPU and at first CPU will look for the data in the cache. If it finds it in the cache, well and good, and if it does not find in the cache, then only it will look in the memory. But if it finds it requires information in the cache, then the access time will be much faster. Now let's see the units of memory. See, for representing various physical quantities, like for representing liquid, we use some units like liter, milliliter. For representing like distance, we use units like meter, kilometer, etc. Similarly, for representing memory also, we use different units. What is the elementary unit of the memory? A bit is an elementary unit of the memory. 8 bits is equals to 1 byte. Now, why have I converted bits into byte? That's because 1 byte is the smallest unit that can represent a data item or a character. You cannot use the elementary unit, that is bit, for representing something. For representing even the smallest of character like full stop or comma or A, B, C, D like this, the minimum amount of memory that you require is 1 byte. Let's know about another term called as nibble. What is nibble? A group of 4 bits is called a nibble. So 4 bits is equals to 1 nibble. We have other higher units of memory which includes KB, MB, GB, TB and PB, which stands for kilobyte, megabyte, gigabyte, terabyte and petabyte respectively. These are its like interconversions. 1 KB is equals to 1024 bytes, 1 MB is equals to 1024 KB, 1 GB is equals to 1024 MB and 1 TB is equals to 1024 GB and 1 PB is equals to 1024 TB. Now we will recognize a certain pattern in these memory units. The pattern is that every higher memory unit is equals to 2 to the power 10 of its lower unit. 2 to the power 10 is equals to 1024. Now if I take the example of kilobyte and megabyte, what is the next higher unit of KB? It is MB. So 1 MB is equals to 2 to the power 10 KB, that is 1024 KB. That's all about the memory. I would like to show you something about like primary memory and secondary memory. Now let's say here I have various images here. Let's open this image. Now before opening it, it is located in the secondary memory, which is solid state drive in my case. Now as I double click it, it will come from the secondary memory to the primary memory, that is RAM. As I have said, RAM stores the data which we are using currently. Okay, I hope you have understood a little bit about memory in this part. In the next part, I'll discuss more about this chapter known as Computer System Overview. Thank you very much. I hope that this session was useful.